Hoorah! Here we are in chapter 4. Now some of this is still going to look familiar to you because you have examined some of it when you were in Algebra 1. You may even have talked about some of it in geometry. But basically we are beginning Algebra 2 at this point. Today, even though I tell you we're beginning Algebra 2, we're going to be talking about systems of equations in two variables. This is not new to you. We'll start with a little review about solutions of an equation. The question here is whether or not this pair is a solution of this equation. So we have an x in this equation, and we have a y, and if the point is true, then I can substitute in the x coordinate, which is 1 for x, and the y coordinate, which is 3, and I will see that that is a true statement, and it is. So my answer here is yes, 1, 3 is a solution of the equation. Try another. 4, and there's my x. There's my y. Now, x is 5. We're going to test this point. And y is 2. See if that turns out to be right. That would be 20 minus 6. That turns out also to be a solution of the equation. So there's a quick way to determine whether or not a point is a solution of an equation. We're going to start out here with graphing, and it's very important to do this accurately. How can you do that? You use graph paper and you use a straight edge. Graph paper and a straight edge. A straight edge does not have to be a ruler. It could be something as simple as an index card, or even as simple as a piece of paper that's got a couple folds in it to give you a nice sharp crease. Any solution gained by graphing must be verified in the equations. Why do you suppose that is? Graphing will show us where we think the answer is, but we might be off just a tiny bit. Now I like to use the slope-intercept form, so I'm going to transform this into the slope-intercept form. It's going to be quite easy to do. You remember the slope-intercept form you've solved for y. All I have to do to solve for y here is divide everything through by 2. So I'm going to have a negative 1/2 x. Notice that I'm rearranging where these two terms sit, and I divide this by 2, it's going to be a positive 3. So now I could graph this line quite quickly. That's why I like the slope-intercept form. I go up 3, and that's my y-intercept. You can anchor your line by doing that. The next step is using the slope to get your second point. Okay, this says that I am going to go down 1 and over 2. I always apply the negative to the numerator, and in that way I'm either going up or down, and then when I do the horizontal I always go from left to right. So I'll go down 1 and over 2. Now once I've done that, it's pretty easy for me to see the other way I could go. So I can mark all these points, and then I have the equivalent of a straight edge here because I can call for a line, which maybe I should control the color of that line, just so it's easy to follow my work here. So this line would look, I'm going to put it right there, and I'm going to rearrange it a little bit just so it's as accurate as I can get it with what I'm working with. There are limitations to what you can do graphically. So there's the first equation. The next equation, I'll use blue to make it clear what I'm doing here. I've got 3x on this side. I want y to be positive, so I'm actually going to add 2y to both sides. I'm going to rearrange things. 2y plus 6 equals 3x. I just swapped these sides. That's perfectly okay. Now I'm going to subtract 6 from both sides. 2y equals 3x minus 6. And my final step, of course, is to isolate y by dividing everything through by 2. So my slope is going to be 3 over 2, and my y-intercept is going to be a negative 3. So here it is at negative 3. Now that I've anchored my line, I'm going to use the slope, which tells me I need to go up 3 over 2. Up 3 over 2. Up 3 over 2. This will give me several points. And now I'll draw my line, and I will choose a good color, something that makes sense for the work we're doing here. Oh, I made a mistake and it's showing up now, isn't it? This is why I recommend that people do people do 3 points when you're graphing a line, even though you technically only need 2. This was incorrect, wasn't it? What it should be, I went up 3 and over 1. I should have gone over 2. And I bet you were trying to tell me that, and I was ignoring you. I am so sorry. That's one of the handicaps of this particular method, isn't it? Try to tell me something and I will not listen. Hopefully, in the classroom, I will. Ah! And we, of course, have a few technical difficulties. Okay, so I am getting an intersection here, so that's a good sign. And at that intersection, which is right here, I think that's our solution, isn't it? That's the single point that both of these share, so that's going to be our solution. If I try to read it now, it looks like it is at x equals 3, and I don't know about this. What do you think? Y is 1.5 or 3/2? Looks like that might be true. Any solution gained by graphing must be verified in the equations. All right, I'm willing to do that. When you do verifying, make sure you go back to the original. So we're going to verify in this one and in this one. The reason we do that is on the chance that when we went to an equivalent equation, we made an error. So you always go back to the original. So I'm going to have 2y equals 6 minus x. And I'm also going to verify the other equation, which is 3x minus 2y equals 6. So let's pop the values in. We say that the point that these two lines share should be true for both these equations. X is 3. Oh, wait a second here. I don't want x. I want the value of x, which is 3. And my x in this equation is right here. Now also pop in my value for y, my y coordinate, 3 over 2. Now let's take a look at this and see if this is true. This ends up being 3 equals 3, so that one worked. And this one turns out to be 9 minus 3. That one works too. So we did verify, and our solution is correct. We should probably box it. Systems of equations in two variables. Here we have y equals 1/10 x plus 1. 1/10. So our slope is up 1 over 10. This one, 1/12. They have different y-intercepts. The blue is right here at 1, and the y is at 2. From this view, it almost looks like these are parallel, but we know that parallel lines have identical slopes. It's supposed to be an equals. These slopes are not identical, and actually if we drew this out far enough, we'd find these lines will intersect. These are intersecting lines because they have different slopes. All right, let's try this one. Let me move to green here. Now this one I actually, in fact both of these, I might actually try doing these with the y and x intercept method, which is when x equals 0. Oh, I didn't want that. When x equals 0, what will y equal? Well, that would zero this out, and I'd have 3y equals 12. Divide both sides by 3, y is 4. And when y is 0, this will zero out. I'll have 2x equals 12. Divide both by 2. So that's actually much quicker, isn't it, than the slope-intercept form. So I've got x is equal to 0, and my, I'm going to have to use 10, aren't I? The 1-by-1 grid isn't going to work here. When x is equal to 0, y is equal to 4. This is going to be a 2-by-2 grid. When y is equal to 0, 6 is going to be equal to this. So if I were to hand draw a line, that's what I'd get. Now we'll try this one. I'm going to use the same method. First we'll say when x is 0, what will y be? That's right, -1. When y is 0, what will x be? All right, so we'll graph those 2 points. When x is 0, y is -1. Oh, except that doesn't match my scale, does it? When x is 0, here's my -1. These are 2-by-2s. How quickly I forgot. When x is 1, y is 0. So here I've got this line. Oh, it's going to be kind of tricky for me to graph, isn't it? Oh, maybe not. Maybe it's not so tricky after all. I just make a note of where I want to land, and I can do it. My slope is a +1, isn't it? So, all right, so I'm going to draw this trying to draw as straight a line as possible. Here I am telling you to use a straight edge. It really is much better. It looks like I do have a solution right here, and I'm going to guess that that is 1.5 or 3/2 for my x, and oh, I forgot again, didn't I? This is 2, 4, that's 3. I change my scale and throw myself off. Okay. So yes, I'm going over 1, 2, 3 and going up 2. So what do we have to do? We have to check that by verifying in the equations. So I'm going to have 2x plus 3y. We're going to test this point and see if it works. And we're also going to test this one, x minus y equals 1. So that'll be 3 minus 2, and this one, I've got my x here and my y here. Let's see, that'll be 6 plus 6 is 12. That works. And 3 minus 2 is 1. That works too, so that's a good solution. Okay, thanks for hanging in there with me. I appreciate it.